Hi everyone. In this lesson, we're going to talk about variables in Java. Now, Java is a strongly typed language, which means you have to specify the type strongly because it's not like Python where the variables are um, can be various types. Same thing with JavaScript, right? A var variable in JavaScript can be an integer, it could be a string, it could be all kinds of things. Well, in Java, it's strongly typed, meaning it has to be a type that they specify. And now an object can be anything, but that's pretty much the only thing. Anything other than object has to be the type that it's supposed to be as far as it's declared. Now, the types that are built into Java, there's primitive types, and then you can create many different objects, and those are also types. And Java provides many of those, and we'll get into those in a minute. But let's talk about the primitive types first. Now, primitive types are building blocks for building your applications. Variables are very important. Without the variables, you can't really do much with a program. Branch logic won't work on static numbers like 5 and 6. Someone has to be able to enter a number in. It gets stored in a variable, and then you do some logic on the variable. So variables are very important in any language. So the ones that are primitives in Java are integer types, and that's a number without any decimals, right? And so they have integer, they have long, they have various sizes of numbers without decimals. But integer and long are the more popular ones. And then they have variables that have decimal values, so numbers that have decimal values, and that's doubles and floats. And then they've got true, false, boolean, and then they've got byte, which is a very small piece of data. So things are all made up of bytes. Like an integer is made up of bytes, a long is made up of so many bytes. So byte is the smallest unit, but you can use it and define it and set it as a variable. Short's a little bit bigger than a byte. And then there's a character, which are the basic building blocks of our string arguments. So strings are things like these words here, any of these letters. So a string is a bunch of characters all strung together. So that's why they call it the object string that characters make up. And we'll get into string in a little bit. Okay, so now we've got a definition of these. Now, integer is for whole numbers. That's not a decimal. And if you just type a number in Java like 5, its default type is going to be integer. And that's what this one is proving here. Now, object can be anything, right? So you set the object equal to 5. We don't know what the type is yet, but if we go ahead and inspect and see what the name of the class that O is holding, we see that it's an integer. And then we can go ahead and test integer and see what the maximum values are. And I don't know what that is. What is that? 2 million? Or 2 billion? Looks like 2 billion something. So there's a min and a max, right? So it goes to negative and it goes to positive max values. Now, a long is the same thing, just a lot bigger in value. And I didn't put the value down here, but it's a lot larger. But same things. Now, you can't just say 5 and expect it to be a long. You have to put something in it to make it a long, unless you declare the variable type as a long. We'll see that in a second. But so 5L means I want this 5 to be a long. And if we store that in the object and then inspect the object, we see that it's now equal to a long type. And the long value, that could be part of your exercise. Take your Hello World program that we worked on before, and then go ahead and do the min and the max and see what it comes out to be. And I think that's what we'll make the exercise for this one. We'll do a bunch of variables and we'll do some things at the end of this as our exercise. Okay, so a long, if you declare it as a long and then you just set it as a number, you don't need the L anymore because it knows that you're setting it as a long. So then it'll turn that 5 into a long, and it's equal to 5L, which is a long. Okay, and now double, that's the decimal number. Now, it's like long is the biggest int primitive, and double is the largest decimal primitive. So again, any of the decimal numbers that you specify without saying the type at the end here or without declaring its type is going to end up being a double. So 5.2, for example, has a class name, if we check it, of double. And double is a big floating point number, which is really large. We'd have to see what that number comes out to. Maybe that could be part of the exercise too. Make this number not be exponential so that we could see how big it really is. And if you want to declare a double, you could just declare the variable double. D equals 5.2, and it'll be equal to the double value. So that 5.2 got turned into a double just by declaring the type. Float is a smaller type, so double is to long as float is to integer. So it's a little bit smaller. So 5f will define this 5 as a float, and we can see that here if we inspect the object. And then the float values are smaller than double, and we should also make that an exercise to do that as well. And so if you declare it as a float here, it'll go ahead and make that 5 a float type. Now Boolean's for true false, so yes or no, and that's just true or false. Set it to the object, it comes out as Boolean, and you could just define it Boolean b equals true, and that's how that works. Now bytes are small, right? It's the smallest building block, and it's a very, very tiny integer. But it makes up, a byte basically makes up almost everything in the, everything stored as a byte. So this is the basic building block here. So we can declare the byte as a 1, and then go ahead and capture the object with the byte and see what it is, and we see here that it's a byte. And then the value ranges from 127 positive to 128 negative on that. Now short's a little bit bigger, so it's a smaller integer. There's no decimals. And then so you declare it as a short, and we capture the object, and we see short, and then it's about 32,767. That's the traditional old-time integer. I don't know how many bits that is, but it's 16 maybe, I'm not sure. All right, so and that should be another exercise that we do. So character is the basic building block for strings. And so you declare a character with a single quote. So I want A to be this character. And then we check the object class, and we see that it's of type character. Now, characters are also integers. You've probably seen an ASCII 2 chart. They've got a number representing a character and then the character itself. So A is actually represented by the integer 97. So then we could see here, just by declaring an int with the character A, we're going to actually get 97, which is the ASCII code for A. And then we see that it's an integer type. Okay, now strings, they're sequences of characters. And so they make up words, sentences, and more. So if we want to store someone's name, their password, their username, their name, their street address, those are all stored in strings. And a string is simple. You just double quote and type whatever you want to in here. It doesn't have to be a single word. It could be space, it's sentences, anything you want to type in there, pretty much. Special characters have to be escaped if they're in there, but we'll get into that later. All right, and you could also create a string this way. No one does this, but you could do it with new string hello. And actually, we do that somewhere in these tutorials. I remember needing to do it somewhere, and I don't remember the case, but it's a very rare thing that anyone types new string. Okay, and then another way to do it is to actually make the character array that makes up these letters. So here's the characters that make up that string, and there's them individually. And then you do new string characters for the array, and it'll go ahead and make the hello string. Now, string is an object, so you can actually do operations on it. So you could see its length, right? So you can set 1, 2, 3. Now see, this is a string, and I could test the length on it, and the length is equal to 13. And I could set that length equal to an integer and do operations with whatever 13 ends up being. You can also turn it into the character array. So I've got hello and turn it into a character array. It ends up being the same array that we used up above. And then you could do things like substring. So I can chop this string into something smaller. So I'm going to chop it from 4 all the way to the end. So I just do a substring starting at index 4 and I put the numbers up here. Java arrays pretty much start, and indexes start at 0 for the most part. So here is 0, 1, 2, 3, 4, and that's how it starts. So 4 is actually where this T is here. And if you do a substring 4, it'll go ahead and get 4 to the end. Now there's another substring that will do a range, right? So we've got 4 to 7. So I want to do, let's go from 4, which is the T, to 7, which is the space. Now the last one doesn't include, so it goes up to, so it goes from 4 up to 7. So it doesn't actually include 7. So it's going to pull out the word 2 here. Now starts with, you can, and there's lots of operations. You could look at the string documentation, which there's a link somewhere in here in this document. So now you can do, does it start with 1? True. And then you get a Boolean. Does it end with 3? True. And you get a Boolean. I can also replace something. So let's replace this word TWO with TOO, and then you end up with this string. All right, and so there's other things you can do. You can do a split, and you can split things. I'm going to split on space, and I'm going to pull out each of the individual words here. So I've got this sentence, and I'm going to pull out split. Index 0 is 1, the next one is 2, and index 2 is 3. So remember, 0 base, 0, 1, 2. Okay, and then we could get parts this way. So instead of doing the split operation multiple times and getting them this way, do it one time, assign it to a string array of parts, and then I could do part 0, part 1, part 2, and get them equal that way. Now reference types, those are in string is a reference type, although it's considered a literal because you can do this to it. So it's kind of a hybrid, but it's definitely a reference type, but it's one of the base types. It's almost primitive, but it's not. Okay, so reference types, and so string is a reference type, and we see that up above. It was included with the primitives because it kind of acts primitive-ish. So now there's date objects, very important class if you're doing anything with dates. And so there's Java support for good Java support for dates now. It was a little bit clunkier before, but it's gotten a lot better. So you can get now, which will get the current date and time. You can go ahead and start operating with it. You can add days. So I could take now, which was June 27th when I did this, and add 30 days. And then it comes out to July 27th. I can also get the month, and it says it's June. I could also get the day of the week, and that's Sunday. I could get the day of the year, so it's the 178th day. I can parse a date, so I could give it a string and actually get the date from it. And then I could actually format the date and get a formatted string like this, Saturday, May 29th, 2021. Okay, arrays. An array is a collection of a particular type, unless you do an array of object, which could be anything for each index. So remember, zero-based again. So here's an integer array, 1, 4, 3, 2. Now it stays in sequence order like this. And then I can initialize an array with 10 slots in it, and those slots will default to whatever the holding type's default value is. So in the case of integer, it's 0. So this will default to an array of 10 zeros. And then you can see here that I'm pulling out the first one from that, and it's giving me a 0. I could get the length of an array. This one says 4 because it's actually this one up here, not the one that I'm using there. And then you can see the indexes 0, 1, 2, 3 is how that works. And then same as we did above, you can get the array values out. And then here's array index 2 is giving me 7 in one of these. I don't know what that is. Let's see, what is this one? I actually don't know what this example is. Let's see. Oh, I'm assigning it. Sorry about that. Okay, so I'm assigning my array subscript 2, which would be this 3 over here, to the value 7. And then if I pull it out, it's coming out to 7. So the third value in is now a 7 instead of what it was, which was a 3. I could also add 2 of them together because remember, they're just integers. So I'm going to take 0 and I'm going to take 1. I'm going to add them together and get the sum. So that's a 2 and a 5, and it's going to come out to 7. Now a list is an array type, or it's an ordered collection, and there's various types of lists, and of course you can make your own, but the ones that are built in are stack, linked list, array list, and vector, and array list is the most popular. It's the one you use the most by a lot, at least I do. And then there's an interface list to make it simple, so you can just assign it to list and whatever the type is. Like here, this is the generic list, and here is an array list. Now this one is creating an array list of objects, so I can store an integer, I could store a character, I could store a string, I could store a float, I could store any object in here, and this type of array. And go through and read this in detail. I'm just going through it kind of quickly to get you oriented. Now, as a typed system, you can actually define a list. So this up here is the same as this default, which is saying it's an object. And as a shortcut, you don't have to specify the type on the right side, but you do have to put this inside to say that, yes, I am specifying the type that's over here. To create a list of integers, very similar, just say I'm going to do integer, and then that's the empty type that says it's integers, and then you just add them to this list here like this, and that's what it comes out to, and so you could get it as an array. Now you can sort a collection by using the collections class and just do the sort method on it, and it'll go ahead and put them in their natural order, whatever the objects are inside of that list. And then you can get the elements in a list just like you could in an array, but this is actually using a function because this is a class object type, and I'm just going to call get index 2 in this case, which is now 3 because it's sorted. and then I can find out the index of what value is 3 and what index position is it. So I'm going to say that, and it's going to tell me it's index position 2, which is this slot right here. And then I could get the size of the list, and it's equal to 4. Okay, maps are key value pairs. So there's a couple of those built in, and then there's lots of third-party libraries for array lists and for maps. Hash map for me is the most used one, and it's just key value pairs, so it's simple. You just do an interface map, and then you say what type it is. It's a hash map, and this is the equivalent of doing objects in this map. So I say put, and that's my key, and then my value is hello. So if I do a put on this, when I say I want the map element key 1, it'll return to me hello. And if I want the map element hi, it will return to me 26. And that's how maps work. And you can see that's how it comes out here. 1 is equal to hello, hi is equal to 26, true is equal to yes, this string. Now that's the equivalent here of mapping an object keys to value keys as far as objects. So object and object keys, object values. And then you can specify the types, which is what you normally want to do. You don't really want to use object unless you need to. So this was a string key, so I'm taking names and say these are tests. I'm taking someone's name, and then I'm mapping it to their test score. So here Ricky scored a 90, Lucy scored a 93, Fred an 80, and Ethel a 91. And so you could use it maps in that way. And so now I want to get the score for Lucy. So I just say map.get Lucy, and it returns me a 93. And then if I want to replace the value for Ricky, because there was a mistake, I just do a put again, and with the key, so it'll take Ricky and replace whatever his score was with an 89. And then if I say, give me Ricky's score again, it'll say 89, whereas Ricky had a 90 before, so miscounted there. And those are maps. And those are all the variable types in Java. And now, of course, it's an object-oriented language. You can extend the language and make as many different types as you want, but these are the primitives and the ones that are most often used in Java. And so go ahead and go through this list in more detail. And as an exercise, what I'd like you to do is take the Hello World program that you have, and I'll go ahead and put this in the lesson plan here as an exercise. And copy and paste or type is probably the best thing to do. Type some of these into the Hello World program, and then do a system out print line on whatever the variable is, and see what kind of values you get. So just go ahead and explore and change things. See these words here? Go ahead and change them to something else, and then do a split. Split on something else, put commas in between, and then do a split on comma and see how that works out. So that's the exercise I want you to do. I'll get a little bit more explicit on some examples of what to do, but always just experiment and do whatever you want to do to learn. Don't just do what the instructor tells you to do exactly, unless you're handing something in, but always experiment and always try to grow your knowledge and see how things work. Okay, so I'll go ahead and make another cut of the video that adds the exercise. But that's the end of this discussion on variables. Thanks for watching. Hi, everybody. Okay, we're back for the exercise that was added to variables from the lesson we just had. So I'm going to scroll down to the bottom because that's where the exercise is. And you can reread through that because it's really just going over stuff that's inside of here, a subset of it, not all of it. All right, so in exercise 3, what we're going to do is print a bunch of variable values. So we're going to take our Hello World application that we modified, and we're going to modify it again, and we're going to print out a value that you make up, or you could use one that's already there, of each of the primitive types. So you're going to create a variable with, let's say, an integer, and then you're going to print it out, and then run it, and then see what happens. And you could keep adding to it, or you could keep replacing. It's up to you. We'll see how we do it. I'm not sure how I'm going to approach it yet either. Then, since I left off the long value in the lesson itself, go ahead and print out the minimum and maximum values of long and see what those are. All right, so for strings, we're going to create a sentence. So you can type out any sentence you want. And then let's see how long the sentence is, so how many characters it is. It'll tell you the length, and print that out. And then I want you to replace the third word, or whatever word you want. It doesn't have to be a third one, but that's just a number I'll throw out there. So replace the third word in the sentence with a different word, and print out the sentence and see how it's different. And then I want you to split the sentence into an array of its words. So create an array of the words. And then I want you to print out the array of the words and then print out the fourth word in the sentence, or, you know, you can print out any word you want. Just experiment. Don't just do what this says here. Mess with it. See what you can do with it. All right, and then we're going to do something with dates. We're going to create a new date that's, you know, now, basically, and then print out that date and see what it turns out to be, and then print the month or the year or the day of the week, anything you want to do. Go ahead and see what you can do with it, but month is a suggestion. All right, and then we're going to do lists and maps. So for the list, I want you to just create an array list of integers, add 5 numbers to the list in random order, so not in sequential order, and then use the collections class to sort the list, and then print out the list to see the new sorted order. So that's an easy one for lists. And then on maps, I want you to create an address book with a map. So it's going to be a string name and a string value, which would be the address. So you're going to add names for the keys, and you're going to add addresses for the values. And then I want you to print out the map and see what the address book looks like after you've added a few names and addresses. And then print out the size. It'll tell you how many entries you have in the address book. And then get an address for one of the names. So say Bob Roberts was one of the names that you entered in the address book. Get his address and print it out. Okay, that's those are the exercises. And go ahead and pause the video here, because I'm going to go ahead and go through it. See if you could do these exercises on your own, and refer to the video back if you need to. And then have fun. Okay, go ahead and pause the video. Okay, so we're back, and you're probably back. I'm going to go ahead and start these exercises. So I'm going to open up my Visual Studio Code editor, and I've got the Hello World program in the state that we had it before with the new greeting class. That was pretty cool. Okay, so that's nice. So I'm just going to delete this, and then it said in the instructions, primitives. So print out a variable value for each primitive type. All right, so let's go up to the top of this thing, because that's where the types are. And you could go through each one of these, like down here. I'm going to go through the list right here. So int is the first one. So I'm probably just going to do a bunch of them. So I'm going to declare an int, and I'm just going to call it I. You can call it whatever you want to, but I'm going to call it I, and let's say 17 is the number. And then I want to print that one out, so I'm going to do system.out.println. And I'm going to start using the help over here to speed up my typing a little bit. All right, so let's do I, and then let's go ahead, save, and then I'm going to run this. And you see 17 printed out. Now, you might want to play with it a little bit too, so let's do this just to see the type, because it's one of those things that we had, right? Where 17 doesn't really say anything about the type, but this will turn it into the type. So let's go ahead and do this one as 18. And then let's get rid of that I. We don't care about that right now. And let's do o.getClass.getName. And let's see what the type of 18 is. Is it an integer? Should be, right? Because that's the default type. So let's save and then debug that. Yep, it's an integer. All right, let's change it to a long. Just add an L. And yep, now it's a long. Let's do, and of course I'm going off the exercise now, but this is kind of fun. All right, so let's see if I could turn it into a decimal just by adding a D. And run it after saving it, and yep, it's a double. Okay, so let's go ahead and continue with the exercise, which is what I was supposed to be doing. But I want you to experiment as well. Okay, so back to the instructions. So that was int, so let's do a long, which we kind of did already, but let's go ahead and erase all this stuff and start over with a long. So long, L equals, long's a big number, but let's just randomly type in numbers here. And then I have to put an L here. I don't know why though. Oh, because it exceeded the length. Let's see what happens if we don't exceed the length. Okay, now it's happy. So I must have typed in a number here that was too big for int, because this is integer by default, right? It doesn't know that it's assigning over here yet until it's run. So I have to tell it, okay, that's a long. All right, and then let's print that out. That's a big number. And we'll debug debug or run. And there's the number right there. That's pretty big. Okay. Let's do, okay, that was long. What's next on the list? Double. So let's do a double. Now remember, double has a decimal, and that's the default type. So 8.9 is going to be the default type. So if I print that one out, and we're going to do D, and let's just run. We don't need to debug right now. So 8.9, so that works. Let's turn it into a float. So is that going to actually, do I need to put the F here or not? Let's see what happens. What's it? Mismatch. Can't convert from double to float. So it thinks this is a double, right? So we do have to put the F. Because remember, it's doing this right side type. So it says default for decimal numbers is double. So it can't take a double and turn it into a float, because a float's smaller than a double. It might not fit. So they throw an error there. And now we do 8.9. So that works. So we learned something there. So that's good. So a double is the number type over here, and the float's on the left side. You can't assign a double to a float. All right, so boolean. Boolean is a true-false thing. And let's do true. All right, and that's going to print out true. It should. So we're not actually doing anything tricky here. We're just printing out what it is. All right, so what I want to do now, there's true. All right, so what I want to do now is do we remember do we do conditionals yet? Let's see, did we talk about those? We, at anatomy, we did calling functions, running variables. Okay, we didn't talk about conditionals yet, so I won't do that. Let's see, so that's it for boolean. What was the next one on the list? Byte. So how do we get a byte? Do we just do this? Would that work? Where's the run thing? There it is. Yep, that works. So that's 1. Let's see, 45. Okay, how about a number that's bigger than byte? Because I think byte went to 127, is that right? So you could always just go to the definition down here, and 127. So let's see if we can set it to something bigger than 127. Let's go 129. And what does it do? Doesn't like it. Oh, because now it's saying it's an int to a byte. So if I made it under 127, would it work? 126. Does it do the conversion then? Yep. So if it's greater than the byte, it won't convert it. So the maximum of the byte was 127. So going over that said, okay, no, it's an integer. It can't be a byte anymore, so that won't work. That was neat to know. Okay, so let's do the minus side of this thing, and I think it's minus 128. And let's go ahead and run that. And obviously I'm doing more than it says in the exercise, but that's what I want you to do too. So this is going to do the same thing with the integer. Yep, can't do it because it's trying to convert from an int to a byte even though it's negative. Okay, very good. All right, so boolean. And what's next? Short and then char. All right, so let's do short. There's an uppercase short and there's a lowercase short. The uppercase short is a object or a class, and same thing with uppercase L for long, uppercase D for double, and then those actually have operations on them that you can do. And we can experiment with that since we're here. Might as well do something fun. All right, so 1, 2, 3, 4. Will short fit in that? And I think I'm making this exercise video take a lot longer than it should because I keep experimenting. All right, so let's run. 1, 2, 3, 4. Let's go bigger. Oops, those are letters. All right, that definitely won't fit in a short, and it's already complaining. It's out of range, too big. Okay. Well, we did one already. So let's do, char was the last one, right? So we're going to do char. equals, or C equals, how about A? How about A? All right, and we'll run that, and that's going to give us a C. Or, I mean, an A. Sorry, the variable name is C. And then we can set it to, how about its integer value? And I equals C. Let's see what that does. Does that work? Let's print out I. Yep, now that's the ASCII code. So 97 is the ASCII code. So you'll get into that later, and some of you might know this already, but there's key codes, a number associated to each key on your keyboard, and then other characters aren't even on your keyboard. And that's the ASCII table. And it's got each key or each character is a value, or a number value, an integer. Okay, so that is the end of that part. Let's go scroll down to the bottom of the exercise again. Sorry if this is making you dizzy scrolling so fast. All right, so next thing we want to do is check the minimum and max value of long. All right, let's do that real quick. So it's long, and that gets us stuff. So let's do min. Oh, I don't need the min of a thing. I just want to know the min value. So that one right there. And I could just system out print line. That's helping me too much on that one. All right, so the minimum value is a big negative number. And the maximum value is a big long number. Oops, not there, right there. Okay, so that's that. Okay, strings, so we're gonna make a sentence. Let's do that first. All right, so it's a string, and we'll just call it sentence, and let's say this is a Java 2. Let's do uppercase Java because it's a name. Tutorial on variables. How does that sound? Okay, and don't forget the semicolon at the end. Okay, so now we've got a sentence, and what's it say to do with the sentence? Print out the length. So sentence dot length. So this is going to tell me how many characters there are. 37. Okay. What else? Sentence. Replace the third word in the sentence with a different word and print out the sentence. Okay. So the third word's an A. I don't like that one. So let's go to the how about this one? I'm going to replace the word tutorial. So I'm just going to replace this word tutorial. So let's do that. So let's do sentence dot replace. And it takes a character sequence, so I want to replace the word tutorial. I'm going to replace it with the word lesson. And then print it out. I think I have to assign it. Let's see what happens. So if I print out the sentence here, let's see if it does the original or if it does the one that was replaced, because I don't know if it does it. I do know, but you might not know. So let's see what happens. So sometimes if you don't know, just try an experiment and print it out. So this is a tutorial on variables. So it printed the original. So let's go ahead and assign this to a new, let's do sentence 2. Okay, and then we're going to print out sentence 2, and that should be different. This is a Java lesson on variables, so that worked. So you have to assign it, so it's not modifying the original, it's actually giving us a new one. Okay, so that's that. What else do you do with the sentence? Replace the third word. Okay, now let's see how many words we have. Don't need that. We want to do sentence dot split. And let's split on space, because that's usually what does something with sentences and words. All right, and so we want a string array, and let's call this words. And let's print it out so we can see it. Otherwise, we won't know what's going on. Okay, and we'll print that. And ooh, it's printing out an array of string like that. So how do we get our words out of this array? Okay, let's see. To get our words out of the this array, let's try something. Okay, so array list was in our exercise. So let's go ahead and do a list, and then we'll make a new array list out of it. And we'll pass in words, because that should work. And you'll notice it helped us and did the imports up here for us, which is nice. Otherwise, we'd have to look them up and see where was array list, where is list, and then we could add it. So now let's see if we print out not words here, but list. And let's run that. Cannot infer arguments of list. Oh yeah. You have to tell it what type it is. So if it's on here on the left side, it'll infer it its words over here. Otherwise, you could put it. This would be explicit on both sides if you did this, and that's legal. But they shorten it. They made it so you can not have to do that. All right. So now let's run it, and let's see what we get. Okay, it still doesn't like that. So let's tell it what it is. And try again. Okay, constructor is undefined, so it doesn't actually do that with that string array of words, which is weird because I always thought that it did. Let's do it this way. All right, so it's always a learning experience, right? So that constructor doesn't exist. So what we can do is we can do an arrays class, and we can do as list, and then we could pass in words. Let's see if that works. Okay, ready? There it is. This is a Java tutorial on variables. And notice the comma, so it's telling us each word. Okay, so now we've got a list. Let's go ahead and what's the exercise tell us to do again? No, I was messing around with Visual Studio trying to see how to get things to work. Okay, so let's see. String, we print the sentence length, which we did. Replace the third word, which we did. Split into words, which we just did. And print out the array of words, which we did. And then print out the fourth word in the sentence. All right, a couple ways we could do this one then. All right, so we can use the original words array, which was the intention of the exercise. So let's go ahead and do that first. Let's do system out, print line, and let's do words. And we want the fourth word, so that would be actually index 3, because it's 0 based, right? What did it say in the instructions? Print out the fourth word in the sentence. Yes, so it's 0 based. So 0, let's go ahead and look at our printout. We got 0, 1, 2, 3. Did it say fourth? Fourth word. 0, 1, 2, 3, 4. Wait, but the fourth word is this one. So 0, 1, 2, 3. I'm not going to count it that way. 1, 2, 3, 4. It's Java, so it's 0, 1, 2, 3 is the index. Okay, that was complicated. All right, so it's 3 is the index. And let's verify that by printing it. Okay, so Java is the fourth word in the sentence, the third index in the array. Wait, index 3 in the array because it's 0 based. See, that's confusing. You get used to it, but see, even it confuses me sometimes, especially when you're mixing, 1-based instructions with 0-based programming. Okay, so that's that one. And what was the rest? And that was the end of strings. All right, so dates, we're going to create a new date for now and print out the date variable. All right, so let's go ahead and get rid of this one. That was a little more complicated than I thought it was going to be. Sorry about that. All right, so let's do a new date, and I think it's local date, or is it locale date? Okay, I don't really know. I don't remember. let's go back to our tutorial. And reference types, there's date, so it's local date. All right, so let's do that. Let's assign a local date, and it's that one, Java time, and let's just call it date. And we'll do local, well, I don't remember. It's local date.now. So even though I've been doing this for a while, I don't remember. So I always refer back to documentation whenever I don't remember something, which is often. And I've been doing this for a long time, so don't be worried if you have to look stuff up. It's part of the job, and it's part of learning. Okay, and let's run that. Okay, today is July 14th of 2021. Okay, what's next? And the exercise, sorry if this is making you dizzy. Print out the date variable, which we did, get the month of the date variable. Okay, so let's go ahead and date dot get day of month, month value, that'll give us the number. Get month, let's see what that does. July. Okay, and just for fun, let's see what month value did. It's going to give us an integer, it says. 7, so it's the 7th. Yeah, that's right. July's the 7th month. Okay, that's it for dates. How about, what was next? Array list, which we kind of played with already a little bit, but let's go ahead and do one. It says create 5 numbers in a random order. Use the collections class to sort the list and then print it out to see the new sorted order. Okay, so let's go ahead and start a new array list. All right, so we want a list of integers. And let's just call it list equals new array list. Okay, so now we're going to add some things to it. So list.add. Let's add 3. How about 19? Would it say 5 numbers? How about 0? Let's do a negative number. And something in between. How about 5? Okay, let's print this out just to see what that does. We're going to print list, and we know a array list print because that's what we did before. Okay, there they are, and that's in random order. So now let's go ahead and sort it. So it said to use the collections class. And we want to sort. And we want to sort the list. All right, and then let's print out the list and see if we need to do a new list variable, or will it sort the list in place? Don't know yet. So let's see if it sorts this list in place, which I think it does. So let's go ahead and run that. Collections cannot be resolved. So let's do this again. So collections. Collections. Okay, there. Dot sort. So it didn't, I must have hit a key that didn't add the import up there. All right, so we're going to print that list. We're going to sort the list and then print it out. Okay, here's the sorted list, and that makes sense. Okay, that worked. What was next? Okay, we did that. So next is map. So this is where we're going to make the address book, and we're going to use string keys and string values. And we'll just probably add a couple entries. So this one is actually kind of self-explanatory. We're going to print the address book out, see how many entries we have, and then get a particular one. And then this is all pretty much driven by you and the names that you put in it. So let's do this. We're going to create a map. And we're going to say it's a string key and string values. And let's call it addresses. And let's do it in, let's just do a regular hash map. That's the one that's used the most. Okay, and so addresses. So we're going to do addresses.put. And let's give it a name. So how about Bob let's just do first names, and then we'll do an address. 123 any street. Okay, that's one. All right, I'm just going to copy and paste that. I don't want to type it again. All right, Bob, how about Bill? And he lives on 2345 that drive. And then one more. And you can make these as long as you want. I'm just doing street address right now. Bill, and how about Tom? And he lives at 12345 Main Street. Okay, so what the instructions say, and then print out the map to see the address book. Okay, so let's do that. What's it called? Addresses? Okay, so let's print that, or run that. Tom equals that address, Bob equals that address, and Bill equals that address. Now notice that it's in a different order than even that I typed in, because a hash map is putting it in the order that it can best pull things out for itself. So there are different types of maps. Let's do a tree map. And let's see what that does differently. And you can look this up. You just basically type in Java maps or map types, and it'll tell you what they are. And I think the actual lesson here did that too. So let's go ahead and run this, and then we'll go look and see if we actually listed it out. Now notice it's in alphabetical order by their name. Okay, let's go ahead and look at the instructions on map. Did we talk about them? Yep, hash map, tree map, hash table, and linked hash map are some of the ones built in. So tree map is sorted. Linked hash map will put it in the order that you entered it in. And then hash table is the same thing as hash map. It's just thread safe if you have multiple threads running. That's an advanced topic. We won't get into that here. Okay, so we printed out the addresses, and we're now sorting it, which is not part of the exercise, but that's great because we're experimenting. Okay, let's see how many entries we have in the address book. Addresses.size. And we run. We have 3. Okay, and then what's the last thing? Get the address for one of the names and print that out. So let's do that. So just use the same one. So addresses dot get for, let's do Bill. And 2345 that drive, and that's where Bill lives. Okay, I think that was the last thing in the exercise, right? Okay, it was. All right, so that's the exercises for variables. Go ahead and keep experimenting and playing around with it, and see you in the next lesson.